let's say this wheel is rotating about this axis, this is stationary, and this is having an angular acceleration as alpha. So the tangential acceleration of this is going to be equal to r into alpha, where r is the radius of this disc or this body, is going to be r alpha. So we say at is equal to r alpha. So the person over here onto the ground, he sees the acceleration of this as 0 and acceleration of this point as r alpha. Now what we do is, we give this center of this wheel is also taken this way with the acceleration a1, right? So if this is taken with a1, a1 gets added over here. This is a1. So if this is O, this is point P. So net acceleration of point P as seen by a person on the ground is what? That is r alpha plus a1. And net acceleration of O as seen by ground is what? a1. If from here we subtract this, that is a net acceleration of this point P as seen by the ground is AP, and this AO is the acceleration of net acceleration of this as seen by a person on the ground is AOG. So if we subtract this, we get obviously R alpha only. From here, this is an important result. What we get is, that is, if we have the acceleration of these 2 points, absolute acceleration with respect to ground, then we can find R alpha by subtracting one acceleration from other. Let's say if this is a point over here, this point has a velocity, this point has the acceleration of 3 meter per second square, and this point also has the acceleration of 3 meter per second square. So it means the relative acceleration, that is AP minus AO, is equal to R alpha. That is, both the acceleration they are same, so there will not be any alpha. But if this is suppose 4 meter per second square and radius is 1 meter, then this acceleration is more as compared to this, so this will be revolving in this direction, alpha is going to be in this direction. And this is going to be, when we apply A is equal to R alpha, when we have to find R alpha, so AP is 4 minus 3 is equal to 1 into alpha, that is alpha is going to be 1 radian per second square in this direction. If we make it 13 in this direction, suppose this acceleration is 13 meter per second square, so alpha is going to be in this direction, that is 13 minus 4. Now alpha is in this direction because the acceleration of this is more as compared to this. 13 minus 4 is equal to 1 into alpha. Now how we are going to use it? At times what will be given is, that is the absolute acceleration of this point will be given and absolute acceleration of this point will also given. Now how to use this in your questions? In your questions it may be given that there is a wheel of, let's say, radius r, or there is a body of radius r, and the center of mass acceleration is given as a2 and this acceleration of periphery is given as a1, and both these accelerations, they are as seen by this person on the ground, and you intend to apply A is equal to R alpha. And if you intend to apply A is equal to R alpha, then this A stands for the relative acceleration, that is, what is the acceleration difference between these two. So it is going to be, if A1 is greater than A2, so A1 minus A2 is equal to R alpha you will be using, and this will be having alpha in this direction. If A2 is greater than A1, then this will be, alpha is going to be in this direction, then A2 minus A1 is equal to R alpha. This will be used number of times in your questions.